Welcome to Daily Papers, the podcast where we break down fascinating new research into plain English.
Today we're tackling a question that anyone who's used an AI chatbot has probably wondered about. Why does it sometimes just make stuff up?
Exactly. You ask it for a recipe, and it invents an ingredient. You ask for a historical fact, and it confidently gives you a wrong date. This phenomenon has a name: hallucination, and it's a huge problem.
It really is, because these AI systems, known as large language models or LLMs, are incredibly powerful. We want to use them for important things like medical research or education, but you can't rely on a tool that confidently lies to you.
Which brings us to today's paper, titled Rewarding Intellectual Humility, Learning When Not to Answer in Large Language Models. It's from a team at the University of Southern California.
I love that title, intellectual humility. They're not trying to make AI less intelligent, they're trying to make it wiser. They want to teach it the three most important words in knowledge: I don't know.
So, how do you teach a complex computer program to be humble? You can't just tell it, you have to train it. The researchers used a method called reinforcement learning.
Reinforcement learning sounds complicated, but the basic idea is a lot like training a dog. You give it a task, and when it does the right thing, it gets a treat. When it does the wrong thing, it doesn't. Over time, it learns what behavior gets rewarded.
In this case, the dog is the AI model, and the tasks were answering really tough questions. The researchers used two sets of questions. One was a bank of multiple-choice questions from medical school entrance exams.
So very high stakes. You don't want an AI just guessing about medical information.
Not at all. And the other set was advanced mathematics problems. Again, a field where precision is everything.
Okay, so they have the AI and the tough questions. What's the treat? This is where the paper gets really clever. They created a special point system.
It's what they call a ternary reward structure. Ternary just means there are three possible outcomes. Outcome 1, the AI answers the question correctly. For that, it gets a +1, a full point, the big, tasty treat.
Makes sense. Outcome 2, the AI answers incorrectly. It hallucinates or just gets it wrong. For that, it gets a -1, a penalty. It learns that this is bad.
And here's the crucial part. Outcome 3, the AI says, I don't know. Instead of getting a penalty, it gets a small, adjustable reward. Let's say plus 0.3 points. It's not as good as getting the answer right, but it's much, much better than getting it wrong.
That's the key, isn't it? It gives the AI a safe third option. Before, the AI was incentivized to always give an answer because that was the only way to potentially get a reward. So if it was only 50% sure, it would just guess.
Exactly. But now, guessing is risky. You might lose a full point. But saying, I don't know, guarantees you a small, positive score. It encourages the AI to be more cautious and honest about its own uncertainty. It's teaching it to hedge its bets.
So did it work? What happened when they ran these medical and math questions through the AI with this new reward system?
It worked beautifully. The researchers found that by setting a moderate reward for saying, I don't know, they could drastically reduce the number of incorrect answers. The AI essentially stopped hallucinating on these specific tasks.
That's incredible. So fewer wrong answers, but what about the correct answers? Did the AI become too cautious and just say, I don't know, all the time?
That's the trade-off they had to manage. If the reward for I don't know was too high, the AI would get lazy and just abstain all the time. If it was too low, it would go back to guessing. They had to find the sweet spot.
And they found that a small positive reward was that sweet spot. It was just enough to discourage wild guessing without preventing the AI from answering when it was actually confident.
Precisely. They also noticed something else interesting. Sometimes a model was so used to answering questions that it was hesitant to ever say, I don't know, even with the new reward. It's like the concept was totally new to it.
So what did they do?
They gave it a little preliminary training first. Before starting the reward game, they first showed the AI a bunch of examples where the correct answer was I don't know. This is a technique called supervised fine-tuning.
It's like they had to give the AI permission first, to show it that abstaining is a valid and sometimes desirable thing to do. Once the AI learned that, it was much better at playing the reinforcement learning game.
Exactly. It's a two-step process for the more stubborn models. First, show them that they can say, "I don't know," and second, reward them for doing it at the right times.
This all feels like a really important step forward for making AI more trustworthy. We're always talking about how powerful these models are, but power without reliability is dangerous.
Absolutely. Think about a doctor using an AI assistant to check for information. An assistant that says, "I'm not sure about that, you should double check," is infinitely more useful and safer than one that just makes up a plausible sounding answer.
Or a student using an AI to learn math. Getting a wrong answer that looks right can be more damaging than getting no answer at all. Humility is a feature, not a bug.
That's the perfect way to put it. This paper shows a practical and effective way to build that feature into our AI systems. By rewarding intellectual humility, we get models that are not only smart, but also wise enough to know their own limits.
So, by giving AI a small reward for admitting uncertainty, we can make it a much more reliable tool for everyone. It's a simple concept, but the results show it could have a huge impact on the future of AI.